Hi and hello, I am Athena Pondian here. Welcome to the Anatomy for the Biomedical Engineers classroom once again. Today we are going to continue the third unit, that is respiratory system. Today's topics we are going to see is the respiration rate and the lung volumes. What are all the lung volumes available and what is the respiration rate and what is the normal respiration rate for the adult and everybody we are going to see in this class. Come, let's start the class. Respiration is nothing but, of course, we all know that it includes inspiration and expiration. That is inhaling of atmospheric air and expelling of the unwanted air present in the lungs. This is considered as a respiration. So this particular inspiration and expiration, how many times this inspiration and expiration happen in 1 minute is considered as the respiration rate. So, inspiration and expiration, this is considered as a one breath. So, how many breaths per minute it's considered as a respiration rate. It can able to vary for different age groups. For the normal adult, that is the age group over 18, the normal respiration rate, that is breath rate, is nothing but 12 to 20. So, in 1 minute, the particular person can able to attain 12 to 20 breaths, then considered as a normal respiration rate. So, if in case the respiration rate is less than 12, or in case if the respiration rate is more than 20, they are considered as an abnormal. This can be measured by using a different instrument. The fiber optic breath sensor is also there to measure the respiration rate, and the spirometer, using the spirometer we can able to measure the respiration rate. This respiration rate play a main vital role. We can able to identify the person is affected by any breathing trouble or wheezing trouble or like that. If there is any causes, we can able to measure using this particular respiration rate. Come to see the lung volumes. Of course, we all know that our lung can able to expand and the shrink. According to the pressure created inside the walls of the lungs can able to expand and the lungs can able to shrink. So that particular lung volume, according to the volume encaged in the inner wall of the lungs, we can able to calculate so many parameters, especially like a total lung capacity, then tidal volume, residual volume. In the residual volume, we can able to calculate the two different volumes, that is inspiratory residual volume and the expiratory residual volume. These are all the things. There is so many things we can able to measure. So what are all the things we can able to measure using the volumes of the lung? We can able to see now. So in the lung volume, the first we are going to see is total lung capacity. So total lung capacity means that the full amount of the volume that the particular lung can be engaged. That indicates that once your maximal inhalation, you are attaining maximal inhalation, how much you can able to inspire yourself, you can absorb all the atmospheric air to fill the lungs. The total volume that is engaged by the particular lung after the maximal inhalation, that is called as the total lung capacity. Okay. Then tidal volume. So tidal volume is nothing but during the normal breath. During the normal breath, we already know that breath includes inspiration and expiration. So during the normal breath, the normal inspiration level, the lung occupied some of the spare volume. That is nothing but the tidal volume. That is during the inspiration or during the expiration, the amount of air that is filled over the lungs, the volume that can be engaged in the inner wall of the lung, that is called as the tidal volume, not in the maximal inhalation or maximal exhalation. Normal breath, during the normal breath, the amount of volume that is engaged in the lungs, that is called as the tidal volume. Residual volume. After your maximal exhalation, please remember, after your maximal exhalation, the amount of air that is remaining, that is present in the volume of the lungs, that is engaged in the lungs, that is called as the residual volume. The amount of air that is present inside the lungs after your maximal exhalation. After your maximal exhalation, the amount of air that is present inside the lung is called as the residual volume. In the residual volume, we can classify two different parts, that is inspiratory residual volume and expiratory residual volume. What is expiratory residual volume? During the normal breath, while your expiration is clot over, inspired and expired. The normal expiration, after the normal expiration, the amount of air that is engaged in the lungs is nothing but the expiratory residual volume. You are inspiring air something. Inspired air, the amount of air that is now, that is left out, that is filled inside the lungs volume, that is called as a inspiratory residual volume. Vital capacity. See, the volume of air that is left out, that is breathed out after the deepest inhalation is nothing but the vital capacity. Okay, so these are all the most important volumes you need to measure. Apart from that, there are so many things out there. What is an alveoli spaces, alveoli volumes, and how much each and every alveoli occupied. These are all the things are also there. But we just know the anatomical, the simple anatomy of all these volumes. That is the total lung capacity, vital capacity, and tidal volume, the residual volume, inspiratory residual volume, expiratory residual volume, everything. So I hope so you just understand this particular tidal volumes and everything. So in the next slide you can able to see the graphical representation of this tidal volumes and everything. That is all these volumes of the lungs. You can able to understand how much this particular thing is required and how we can able to calculate all these things can able to display in the next slide. So that's all about today's class. I just crossed over the two important topics, that is respiration rate and the lung volume. So in the next class, we are going to see the next important topic of your respiratory system. Till now, it is signing off from Athena Pondian. Thank you.